What's up there, Math Nation? Mr. Cornell, ready to go over some congruent chords and arcs with you. Okay, so quick sum up recap of what those even are. So if you have a little circle right here, and there's your center. If you drew a line or a segment that does not go through the center, okay, it could kind of be anywhere, as long as it's not going through the center, that's a chord. And then remember, when you mark some points over here, that distance between those points, those are called your arcs. So we're going to look at ways to have congruent chords and the way they make some congruent arcs as well. So two chords are congruent if and only if they are equidistant from the center. So if here's your center, this distance here, FE, would have to be congruent to this distance here, EG. So that's what they're saying, they are equidistant from the center. So if you knew that, then you can say that this chord here, which is AB, and this chord here, which is CD, are congruent. So I just said CD would be congruent to AB. Now, if that's true, then the arc that was created from making chord AB, so here arc AB and arc CD, would also be congruent. So then arc CD would be congruent to arc AB. So that's one way of looking at it. Okay, another way is their corresponding arcs are congruent. So that's what the whole if and only if statement's about. So if you can go one way, then you can go the other way. So if I'm telling you that the arcs are congruent, I'm telling you AB is congruent to CD, then their chords would also be congruent. So it's just basically writing the same thing. AB arc congruent to CD arc would then be congruent. Chord AB would be congruent to chord CD. So there's your first part. Okay. Next part. Looking at the diameter here. Okay, so if a diameter or a radius, so in this picture here it's a radius, so radius EH, and then you have radius EI here, is perpendicular So if the diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So what that means is, in this, like we said, in this case we had a radius. So the radius is perpendicular to the chord, and that's what they're showing right here at AB and EH. Then what that does is it bisects the chords, so then AF would be congruent to FB, and then in doing that, arc AH would be congruent to arc HB. All right, so then if I write this out, what I just said, EH being perpendicular to AB, and then if you go to the other side with EI and CD, okay, so if they're congruent, then the arcs would be congruent. So AH is equal to HB. Okay, so there you go there. So let's do some practice problems with that. So here I'm showing you two chords, SR, ST. I'm telling you they're congruent. So then that means that these two arcs right there, they're also going to be congruent. So 7x plus 24 would be equal to 115 degrees. So then just go ahead and do some math. Move that 24 to the other side. You're going to get 91. Divide by 7, and you have 13. Find the value of x. There you go. Same question. Here's that if and only if, working backwards. So now I'm going to tell you that the two arcs are congruent. So that means that the two chords would be congruent. Okay, so you can set them equal to each other. So then you'll have 18x is equal to 56, and that x is equal to 3. Okay. Oh wait, nope, I did the math in my head. It didn't make any sense. All right, pretend I didn't say anything. So 18x minus 2 is not equal to 54, it's equal to 52. Then you move this 2 over. That's where I was getting the 54 from. And there you go, there's you got your 3. All right, so there's number 2. All right, so now let's kind of wrap everything up that we've been doing over the last few days here by taking a look at this question. So I am giving you, this is, remember, it's called an inscribed angle here, created by these two chords that are congruent. So if those two chords are congruent, then these two arcs are also congruent. And then I'm giving you this guy here. So if you look at this, you had 1, 2, 3 arcs in this circle. And remember that if you have all of the arcs, that should equal 360. These two arcs we just said are going to be congruent. So you can just go ahead, add 6x minus 20, 6x minus 20, and 76. 6x minus 20, 6x minus 20, and 76, and that's all going to give you 360. We'll combine like terms over here on the left side, so 6x plus 6x is 12x, and then we're going to have plus 36 is equal to 360, and then we're going to get 12x equals 324, divide by 12 and you have 27. All right, so there's kind of summing up the things that we've done for the last few days. All right, so that's working with chords and arcs. Now let's take a look at that second part of it. So it says DE is 11x plus 15, and FG is 32x minus 27. So a lot of people are just going to look at this and say, well, here's a chord and here's a chord, and since they're giving it to me, that must be equal to. Well, obviously, because that's what we're working on today. But understand why that's allowed. Because I'm telling you that the distance from the center to the chord is congruent, and that allows me to say that 11x plus 15 equals 32x minus 27. Okay? So then we're going to do the math. Move whoever you want to move. Move the 11 over here, you'll get 21x. Move the 27 over here, I'll get 42. And then I'm going to get x to be 2. Okay? Hold the phone. Find x. This one said find DE. So then that means I'm going to have to go ahead and substitute that in. So I'm going to do 11 times 2 plus 15, and we'll get the answer to be 37. So there you go there. There's number 4. Okay, now let's take a look at 5. Again, very similar. If I take a look at this, I'm showing you that these arcs right here are congruent, so that means that the chords are going to be congruent. They're showing me an equidistant because I'm perpendicular here. So let's go ahead and plug it in. NP is 5x minus 34, and PN is 2x minus 4. So again, that distance right there has to be equidistant because of what I told you up here. So 5x minus 34 equals 2x minus 4. 3x is going to be equal to 30. So you're going to get x to be a value of 10. Now it says to find the value of MP. Okay. So I'm going to have to do 5 times 10 minus 34, and that's going to give us 16. All right, so if you feel pretty good, you're feeling pretty comfortable, try number 6. Ignore all of this because that's going to be down there. So you can try to answer this question here. So they're telling me QM is 6x minus 11, and MR is 2x plus 9. And they want me to find the distance of MN. So what you have to do is take a look. Well, they're giving me this distance here and this distance there. Because of what they're telling me here, equidistant from the center to the chord and your perpendicular, that means that these guys bisect. So that means that 6x minus 11 is going to be equal to 2x plus 9. Then we can go ahead and do some math. 4x is equal to 20. X is equal to 5. But they did say to find MN. So that what you're going to have to do is do 2 times 5 plus 9. That's going to be 19. Not there yet, though, because 19 is only part of the chord. So again, to bisect means to cut in half. So if this guy was 19, then the other side's going to be 19. And 19 plus 19 is going to be 38. And that's going to be your final answer for question number 6. Rolling on down, last 2 questions, number 7 and number 8. Okay, 7 is an onion, an ogre from Shrek. That's what this one is. It's an ugly question, but we're going to just start peeling it away, and it's going to be beautiful in the end. Question 1, find VW. Okay, so that's this chord right here drawn there. Now, this here is the radius. The radius is perpendicular, which means that this chord was bisected. So if I know this distance, I could find that distance. And because of this being a right triangle, anybody want to scream out the formula that I'm going to use? Correct, the Pythagorean theorem. So 5 squared plus x squared equals 13 squared. Bingo, bango, bongo, you're going to get 12. Okay? This distance is going to be 12, which means this distance is going to be 12, which means VW is 24. All right, so there's part 1. Not too bad. B, on the other hand, is asking you to find arc YW. Has absolutely nothing to do with what we learned today. And it has everything to do with what we learned in some past lessons. So if I jump to another page right here quick, and I just clean up that picture, this was the center, here was a radius, and there was a radius which was drawn. And then there was that chord that was right here. This was in the center. They're asking me to find the distance of YW. What is this called? Or you're going to use the central angle, right? So if I know this angle right here, that's going to tell me this chord right there. But they didn't tell me that angle. They're just showing me that I have a right triangle and the 3 sides are 5, 12, and 13. I need this angle right there. Anything potentially coming to mind on what ways, okay, you can do to find an angle? Okay, remember there are 2 ways to do this when you have a right triangle. This Pythagorean theorem is one formula. That's to find sides. The other way to find sides is using trig, SOHCAHTOA, sine, cosine, tangent. That allows you to find sides, and it also allows you to find angles. And that's what you would have to do in this case. So the opposite of the 90 is the hypotenuse, opposite of the angle is opposite, and then the final side is adjacent. So here you go, you have your triangle labeled. Okay, now you have all 3 sides, so it doesn't matter which one you do. Let's say I'm going to use, I don't know, opposite and adjacent. Let's use the tangent function. So I would say tangent of angle x is opposite, which in this case is 12, adjacent, which is 5. Now to remember to find an angle, you have to hit second and then do 12 divided by 5. So if you're doing this with me, if you're trying this, hit the mode button on your calculator, go down and change it to degree mode from radian to degrees, otherwise you're not going to get the right answer. And you should have 67.38. So if you have some weird, ugly decimal that doesn't look anything like that, again, mode, make sure you're in degree. All right, and there it is. There's your ogre. If we want to get away from that, try number 8. 8 doesn't have anything crazy like that. So here we go. 8. They're telling me this chord right here is 18. Okay, the whole thing, not just the RW. And then they're telling me that this arc right here is 42 degrees. And then they want you to go and find all this stuff here. So the first thing they want me to find is side here, TV. Okay, TV. Now, because I have 2 chords that are equidistant, I know that they're both congruent. So that means that this whole thing, TU, is also going to be 18. 90 degrees, that means bisect. Bisect 18 becomes 9. That right there, also going to be 9. Okay, rolling all our rules into one question here. If this arc is 42, then this arc is 42 because of this whole bisecting rule. That means this whole entire arc is going to be 84, which all of that can get translated over to this side. So that means YU is going to be 42. RS is going to be 84. All right, so that's it. That's everything you need to know about congruent chords and arcs. Like, comment, subscribe, have fun. See you on the next video.